Okay. So, respected committee members, colleagues, and guests, my name is Theoklitos Klitou, and I'm pleased to present the outcome of my doctoral research titled An Integrated Digital Platform and Reach the Building Intelligence through the BIM, VR, and the SRI. Okay. This work has been carried out under the supervision of Professor Dr. in Paris Fokaides at the School of Engineering at Frederick University, Cyprus. Okay. This presentation is divided into 5 main parts. I begin with an introduction where I set the context of the energy efficiency and the smartness of the buildings. The second part covers the theoretical background where I review the SRI, the BIM, and the VR, while also identify the research gaps and my objectives. And the third section explains the methodology, describing the research design and the framework. In the fourth part, I present my results and discussions, which includes the Smart VR platform, both the backend and the front end, and its validation through the 2 case studies. Finally, I end with my conclusions and summarizing my findings. Let's start with the introduction. Buildings in the EU consume about 40% of the total energy and generate 36% of CO2. So they are the heart of the climate and the energy policy in nowadays. Improving the performance is no longer just about the insulation or the renewables. Its focus shifts to the smart technologies that makes the building more intelligent and interactive with both the users and the energy systems. This is where the Smart Readiness Indicator, or SRI, comes in. Under the revised EPBD on 2024, it will become mandatory for the large non-residential buildings from 2027, making a major regulatory step to promote the smart buildings technologies across EU. So building efficiency means using the energy, water, and the resources wisely to cut waste and costs while keeping the comfort high. The benefits are clear: cost savings, smaller environmental footprint, and better living conditions, for stable temperatures to cleaner air. Efficiency is not just about numbers. It's about creating a smarter and more comfortable space. When we talk about the smartness of the building, we mean its ability to interact intelligently with both people and its environment. According to the European Commission, SRI, this idea is to build around 4 key capabilities. First, a building must be able to sense conditions, things like occupancy, temperature, daylight. Second, it needs to interpret with the data in real time, spotting patterns and recognizing when systems need to be adjusted. Third, it should be able to communicate not only with its own system, but also with the widely energy, the grid around it. And finally, it must be able to respond, to act automatically, like dimming lights, adjusting the ventilation, or shifting the energy loads, when all this without the human intervention. So these pillars are the heart of the SRI, and they define how we measure and improve the building intelligence. Smart buildings are not just about adding new technology. They change the way we live and work inside of them. They make the energy use smarter, matching demands with the renewables, like the solars, and improving how we store that energy. They can even predict problems before they happen, keeping the systems reliable and reducing the downtime. And for us, as users, they make the spaces more comfortable, with lighting, heating, and cooling that adapt to our needs. So at the end, smart buildings are not only efficient.
'Cause you have comments. Is it? 'Cause you have comments. 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 'Cause you have comments.
Video.
Sorry, we cannot hear.
Yes, we lost
Hello.
sound. Yes.
Do you hear me?
Now,
Now,
yes, yes.
Okay.
Okay, so do you see me also or just the
Yes,
screen?
yes, we can see you. You can hear you. Please proceed.
Okay. Okay. Now, this section outlines the theoretical background that forms the foundation of this study. It focuses on the three central components relevant to the industry: the SRI as an assessment framework for the smartness of the buildings, the BEAM, and the VR as enabling technologies for that. Now, before moving on, I want to explain why this work focuses on these three. The policy driver is clear. The SRI becomes mandatory for large buildings from 2027, but current methods are complex and not widely adopted. And on the technology side, BEAM enables the structured data integration, while the VR provides the immersive interaction between experts and non-experts as users. And yet, these tools remain isolated. And without integration, their potential is limited. This gap is what my research is addressed. Now, starting with the SRI. The SRI was introduced by the European Commission in 2018 under the revised EPBD. It evaluates how well building systems can monitor conditions, respond to the users, and adapt to the signal of the grid. It's modular, and technology-enabled design makes it scalable across different building types and member states, while supporting the energy efficiency, occupant comfort, and the system flexibility. In short, the SRI provides a structured EU-wide method to access how ready a building is in order to interact with both its users and the energy grid. After establishing the meaning of the SRI, let's now look at how it works. This slide presents an overview of the SRI methodology. Here are the three core functionalities, which are the optimization of the energy efficiency, the adaptation to the occupant needs, and the response to the grid. So these are the backbone of the SRI logic. These core functionalities are evaluated through 7 impact criteria that reflect the benefits of the smart services. Energy-related impact include the improved energy and the proactive maintenance. The occupant-focused impact covers the comfort, convenience, health, and access to the useful information. And the final group, energy flexibility and storage measures and building's ability to respond to the grid needs through the adaptive energy use. Now, on the right, we see the 9 technical domains through which the smart readiness of the building is assessed. These span up across the HVAC, the lighting, control systems, and electric mobility. Together, they form the basics to evaluate the building smartness. Now, this is an example of what the results looks like. Here we have a building of score 52% in the class D. The 3 core functionalities are shown separately on the right, and the detailed matrix on the left, which highlights how each domain performs across the impact criteria. Now, for example, domestic hot water here scores very high, while the ventilation and the monitoring performance are much lower. So we see the monitor and the ventilations that are very low. This kind of breakdown helps to identify the strengths and guide upgrades where they are most needed. So here we see the 3 methods that we can apply in order to have to find the score of the SRI. Method A is the simplest, a checklist that users can complete themselves, but only for homes and small buildings, and it takes less than an hour. Method B is a more detailed, led by the technical experts and suited to larger or complex buildings, usually taking half a day to a day. And the method C is the most advanced, using measured performance data collected over time, and typically is non-residential buildings that are already in operation. So these methods make the SRI flexible and adaptable to the different real-world situations. Now, to demonstrate how the SRI framework is applied in real case, this video walk through us how the official EU SRI Excel tool works. So we start with the built-in information, where we complete the accessory information, the built-in information, the built-in type, the usage, the location, and the area. And then we move to the methodology. We select which method we want to use and the different what domains are present in our buildings. Now, moving to the calculation, we select for each service, smart ready service, what functionality level is suitable for that service. And we go through all these smart ready services in the Excel. And we select, now here we have the different functionality levels, and we select which one is more suitable for our case. And in the results, we have the class, the impact and the criteria we have, and also the detailed scores. This is the official SRI tool. Now, despite this promising potential, the current practices of the SRI still face several obstacles. Firstly, assessments are mostly manual and heavily related on expert input, which slows down widespread implementation. Secondly, there is a noticeable lack of comprehensive digital tools that could simplify or automate parts of our process. And lastly, stakeholder engagement remains low, which weakens both awareness and the market traction. Now, moving to the built-in information modeling, BIM is more than just a 3D models. It's a digital representation of built-in features and functions that supports the decision-making throughout its entire life cycle. It started with the 2D CAD drawings and has since evolved into detailed 3D models enriched with the metadata about the systems and components. Today, BIM enables collaboration across architects, engineers, and contractors, and facility managers also, ensuring everyone works for the same reliable source of information. The role of BIM in the construction is the project planning and execution, where the BIM provides detailed visualization that help in identify the potential issues such as spatial conflicts or design errors early in the project. Data management, where the BIM centralizes the project information, making it accessible to all stakeholders. This centralization improves the data accuracy, facilitates in real-time updates, and ensures consistency throughout the construction process. And finally, the interaction with the other technologies. BIM is already benefit from the integration of VR and AI, and its future integration with the SRI framework presents a significant potential. Now, moving to the virtual reality. VR creates the immersive simulation of a real-world settings using a headset, controllers, or mobile devices to let the users explore and interact with the virtual spaces. There are three main types: the headset-based, which gives full immersion by blocking out the real world. The stationary-based, like the cave system, where users are more limited in the movements, but still highly immersive to the immersive reality. And the hand-based VR, the last one, which users use the table or smartphones, making it more accessible, but less immersive. So each type has its role, ranging from the high-end design to training to the lighter educational uses. Now, let's look at how the virtual reality is already transforming the construction sector. Design and planning, VR lets the architects and engineers work through digital models before construction begins. This improves the spatial understanding and helps spot issue early in order to saving the cost and reducing the risk. Safety and training, workers can practice operational machinery or handling hazardous situations in a risk-free virtual environment, and this builds skills, confidence, and safety awareness without any real-world consequences. And last, the project management and collaboration, where the VR allows stakeholders to meet inside a model itself, making coordination cleaner and preventing the misunderstanding and speed up the decision. Now, let's talk about why integrating VR, BIM, and SRI really matters. First, it improves the visualization, the planning, with VR and BIM, we can step into the building before it's built, spot issues early, and make better design decisions. Adding the SRI now ensures that the energy efficiency and the smart readiness are built into the process from the very start. Second, it boosts the collaboration. VR allows teams to engage in real time. BIM centralizes all project data, and the SRI use that information to evaluate where the smart technologies can add the most value. Together, these tools create a more connected, efficient, and proactive way to design and assess the buildings, leading to smarter and better performing outcomes. Now, here I present the main research gaps and the questions that guide my work. Gap 1 is the lack of integrated platforms. At present, BIM, VR, and SRI are mostly used in isolation. The first research question therefore asks, how can integrating these technologies into a single platform improve the user engagement and enables immersive real-time building assessments? The second gap highlights the needs of a simple, user-friendly SRI platform. Yes, I have a mistake here, sorry. The second question asks, how can method A be simplified through the adaptive and easy-to-use tools? And finally, gap 3 addresses the solutions. The third question is, what features enable the scalable SRI tools that can also provide tailored upgrade recommendations? Together, these questions frame the development of my integrated platform and establish the foundation of the methodology I will present next. Having identified the gaps now, here are the 4 main objectives. First, to develop a web-based platform that integrates the SRI, the BIM, and VR into one environment. Second, to enable the immersive interaction with the digital building models, providing a real-time feedback on smart readiness. Third, to simplify the method A of the SRI through a dynamic questionnaire, make it more intuitive and accessible for the non-experts. And finally, to add an advisor module that gives tailored recommendations on how to upgrade and building smartness based on the assessment results. In this section now, I present my methodology, covering the key operational stages, the technologies applied, and the main functionalities that enable the platform's assessment and the user interaction. Here we see the key stages of my methodology, leading to the development of the integrated platform. It begins with the data collection, where the BIM files are standardized for the VR use. Next, the BIM and the VR integration, bringing these methods into an immersive 3D environment. The third step is the SRI analysis and the advisor, which uses a simplified SRI tool and suggested tailored upgrades. We move to the object property visualization, where allows the users to access the data like the U values, sensor readings, and IFC parameters directly into the VR. Step 5, the virtual navigation with the real-time scoring, enabling the users to explore the buildings and receive the SRI feedback. And finally, we reach a validation where the platform is tested through real-world case studies. Now, moving to the methodological components of the research. Starting with the BIM. The methodology relies on models imported in the FBX and JSON and MTL formats through the Autodesk platform services. Once uploaded, the models are securely stored and translated into the VR-ready environment. Importantly, these models support the object-level metadata, zoning, and map system details, of which help the users to complete the SRI assessment. Moving to VR, the platform was built using the 3GIS and the WebXR integrated with the Autodesk Forge Viewer again. This setup enables the immersive navigation of the BIM models with the real-time interaction. Beyond simple visualization, the VR allows the addition of tooltips, overlays, or selectors, which give the users more spatial understanding and access and data-level data inside the virtual environment. Now, continuing the methodology for the third component, which is the SRI tool. I applied the simplified method A, implemented through the dynamic multiple choice questionnaire. The backend is developed into the C# and is directly linked to the smart readiness services codes. This setup ensures that scoring happens in real time, and once the assessment is complete, the platform automatically generates a digital certificate. The fourth and the last component is the SRI upgrade advice. The module is based on the backend efficiency factors, following the standards of 52.120 of 2022 and the 15.232 of the 2017, and it computes the potential energy savings, investment thresholds, and the feasibility of the different upgrades. Users can test different scenarios by entering the financial parameters, such as the internal rate of return, the cost of energy, and the tool then outputs domain-specific savings and provides a clear recommendation for the retrofit strategies. Here, I show the main functionalities of the platform. It begins with a data import, where BIM files and metadata are uploaded into the platform. Then we have the BIM integration, which interprets the data and prepares it for the VR environment. The VR module allows the immersive 3D navigation of the building, helping the users in order to better understand the layouts and the systems that are inside. Then we have the Quick SRI tool, which is a simplified method A with an interactive questionnaire that makes it process easily even for the non-experts. And finally, we have the Upgrade Advisor, provides a tailored recommendation and highlighting the most cost-effective improvements. All these together make the Smart PR a single, integrated, and user-friendly platform. Sorry. Now, in this section, I present the Smart PR platform architecture and interface. I illustrate the key screenshots, followed by the 2 case studies at Frederick University that test in real-world applications. This figure shows the Smart PR platform's architecture. At its core, it combines the Python backend with the web-based frontend, data from the BIM tools like the Revit and SketchUp, where we save them as FBX format. It's processed and rendered into the 3D through the VR module. Behind the scenes are the 2 engines driving the platform, the SRI calculator engine and the scoring, and we have also the Upgrade Advisor for the tailored recommendations. These run as independent services, which supported by the secure database and authentication for data integrity. And the whole system is modular and service-oriented, which makes it flexible, scalable, and future-ready. Now, to make it user-friendly, I have also developed detailed manuals. These walk users through everything from the file upload to exploring the buildings in VR, as well as how the use of the assessment and the advisor tools can be used efficiently. Okay, this figure illustrates a section of my backend code. At the left, the code loads the models on the Autodesk Forge, and on the right, it sets up the VR scene, letting the users explore the buildings in 3D straight from the browser. It's a code that brings the platform to life. This diagram now shows how the backend of the Simplify SRI tool works. It all starts with a few key details about the buildings, its types, location, which domains are present. Based on that, the system generates a short tailored questionnaire. The responses are then processed in calculation engine, which instantly gives you the SRI score. That score is visualized on the screen and also embedded into a digital certificate, ready for the users to download it. The SRI short questionnaire is structured as a 20-question checklist, allowing for a quick self-guided assessment to be completed in under 10 minutes, making suitable for non-expert users and scalable for large-scale implementations. A related short service is applied to each question. What I mean here. So all these are the Smart Readiness services. As we see on the Excel, each row is one of the codes here. So we make a question that is easier to understand for the users, for all the users, not only the experts, in order to complete the questionnaire. And we see that for some of them, we have 4 questions related to that question. This diagram now shows the backend of the SRI upgrade advisor. We start by entering a few simple inputs, like the building type, the size, and the current energy cost. The system then incorporates technical parameters such as the functionality levels and expected savings from the potential upgrades. The Python-based engine processes all of these and estimates the expected energy and the cost savings, helping the users to make smarter upgrade decisions. Okay, so this slide now is how the SRI advisor calculates engine works on the backend. The calculations are based on the data set built in an Excel file, which includes the control level, the saving coefficient, and the energy thresholds. Here you see an example of the heating emission control. As the control level improves, for example, moving from 0 to 3, here, the system applies a different saving coefficient and translates them into energy saving in kilowatt hours per square meter. This structure allows the advisor to run upgrade scenarios and give clear results on potential savings and investment needs. So from the back coefficients that we have here, the control levels, this is each functionality level. The coefficient of savings are calculated based on the previous functionality level and to the one that we want to move on. And then we measure the coefficient of savings. For example, is that one divided by that one. And then depending on the energy, the cost of energy that we have, we can predict the energy savings of our upgrades. Now, moving to the front end, this slide presents the home screen of the SmartBear platform. On the left side, users upload 2 complementary files, a JSON file holding the metadata and an MTL file defining the materials. On the right side, we have the FBX file containing the 3D geometry as an interactive BIM viewer. All 3 are needed to prepare the BIM model for processing. This view lets the user explore the building models in details, providing a clear spatial overview before moving to the assessment process. So here I have a video of how the upload files work. We choose our file, first of all, the JSON file, and then we choose the file for the MTF file, and we need to be sure that the names are the same exactly for both files. And then we save them to our server. And also the FBX file must have the same name with these 2 files. Now, about the immersive VR environment of the platform. On the left, a virtual room reconstructed from the BIM data let the user walk through and explore the space in 3D. And on the right, the SRI score. The tool is built into the VR interface and giving the SRI score. Using the controllers, the users can point, navigate, and access detailed metadata, such as the materials, structure, and the energy data, making the process intuitive and accessible even for the non-experts. Here again, we have a video about the VR. So we can move with our right hand and point on different components into the VR. So here we see a full detail of the VR interface, and with our left hand, we can see all the metadata of each component, and by clicking on the SmartBear, it directs us to the SRI tool. Now, this is the SRI assessment, which builds into the SmartBear platform. On the left, users complete a dynamic questionnaire tailored to their building types and systems. So these are the questions that we showed before that are related to each smart services of the Excel. And once they submit, the platform instantly calculates the SRI score, shown here on the right, with both the class ratings and the percentage, which are these ones. It also breaks down the score across the 3 core impact areas of the SRI, helping the users to understand where improvements are most needed. The process is straightforward and designed to make the SRI evaluation accessible to all building stakeholders. So what we have done here is we make the SRI tool much more user-friendly and easy to understand for experts and non-experts. And also we have a better graphically certificate as an outcome. And here is a video of how it works. Yeah. So this is our SRI tool. We go through the edit project again, building name and building type, and we go to assessment. For each question, we have a drop-down list that we need to select one of them. And depending on the domains that I select before, it gives us different questions, depending on the domains that are present. So after I have completed my questionnaire, I click Save, and I move to the certificate. So this is a real-time certificate that the platform can give us. And I also can see the 3 pillars, the detailed scores, and also I can download as an export of the PDF. I also have more options to see each score separately. Now, this slide here presents the interface of the upgrade advisor. On the left, users can configure the basic economic and technical inputs, such as the energy cost, current SRI score, and the desired level of system upgrades. Once submitted, the system processes these parameters and generates a detailed breakdown of potential energy savings, allowed investment, and the cost effectiveness across the different building services as shown on the right here. So here we have for the different services, and we have also a total cumulative that shows the total energy saving. Now, this feature is designed to support the strategic decision making by the highlighting where the smart upgrades deliver the most value, both in terms of the performance and the return of investment. I also have a video of how the advisor works. After we complete the SRI, we move to the advisor. We select which domains we want to edit. We select the cost of energy, the IRR, and the upgrade functionality level from which level we want to move to the next. And I have the results. And if I click them to proceed, I have the total upgrades that I have done, the different upgrades, and I have also the total cumulative here for the energy savings. Okay, to test the Smart PR platform, I carried out 2 case studies at the Frederick University. The first was the search offices in the library using a detailed BIM model, and the second was a new wing, which has a simpler model, including only the map systems. In both cases, the SRI was calculated with the EU tool and the Smart PR tool, giving the identified results. Then I applied the upgrade advisor to simulate smart upgrades, estimate the energy savings, and recalculate the SRI in order to track the improvements. Now, this slide shows the search office, one of the case studies that we have. On the left is the office 214, and on the right is the office 213, with the real photographs compared to the VR counterparts generated into the Smart PR platform. The BIM data was converted into the immersive VR environment, keeping all the details like furniture, layout, and equipment impact. The purpose here is to show how closely the VR can replicate real spaces. Beyond simple visualization, it allows users to navigate and interact with the environment, making assessment more engaging and supporting better decision-making. Another example from the search office, where the VR environment uses in order to access the metadata from the built-in components. On the left, we see an air conditioning unit, on the right, a lighting fixture. When hover over the VR, detailed metadata appears. As we saw in the video, on the left hand, we have all the data by pointing with our right hand on the component that we want. So this feature demonstrates the real value of linking the BIM with the VR. It lets the users to access object level information directly inside the immersive environment. So in practice, This supports more informed analysis and prepare the ground for using the SRI tool later. Now, the SRI process starts by selecting the built-in domains. In this case, heating, cooling, lighting, electricity, and monitoring were selected. The platform then guides the users through the multiple choice question. For the offices, we report basic systems like heating and cooling are controlled with manual and no green interaction, or scheduling and non-performance data is selected, as we have here. These answers reflect the real operational conditions of the office. Once completed, the system processes the responses and generates the SRI score in real time. These ones. Here we see the results. On the left, they come from the official European Commission tool, and on the right, from the SmartWare platform. Both outputs are identical, with a total score about 17.9%, placing the building in the class G, showing clear potential for improvements, of course. And the breakdown highlights the strengths in health and well-being, but are very low performance in areas like the energy flexibility and storage. This comparison proves that the SmartWare is fully aligned with the EU methodology, while offering a far more user-friendly and automated interface. Now, we see the outcomes from the SRI Upgrade Advisor applied to the offices. 3 upgrades were tested: motion sensors with dimming for lighting, central interface for monitoring and control, and smart meters for real-time energy tracking. Together, these measures cut total energy use by 15% and boost the SRI score from 17.9 to 29.2, moving the building from class G to class F. Having completed the research offices, we now turn to the second case study, the new wing. This larger multi-use facility includes lecture rooms, offices, and canteen. On the slide, you can see that the real entrance compared to the VR representation. Unlike the search offices, where we work with a highly detailed BIM, here the model focuses mainly on the geometry and the map systems. This allows us to test the platform under different conditions, with less detail but greater built-in complexity. On the left here, we see a photograph of the electrical panels and the switches, while on the right is the same elements are presented into the VR. The platform not only visualizes the geometry, but also links each component to detailed metadata, such as the circuit information and load data. This functionality is not limited to a single room. It can also apply across the 3 floors and every occupied space in the building, providing a comprehensive view of its systems. Now we complete the SRI questionnaire about the new wing building. For the heating and cooling, we select individual rooms control. Each area runs on its own systems without any central automation. Reporting is limited to basic operational data with no advanced monitoring or predictive features. And on the electricity side, feedback is available only at the building level with no storage or grid interaction. Finally, system automation is entry manual as there is no digital management platform in place. This slide presents the SRI results of the new wing, both again the European Commission tool and our platform on the right. So the building again reached an overall SRI score of 38, which in both cases are similar, which places to the class E. Stronger performance comes from the heating, cooling, and partially automated lighting, while domains such as the ventilation and the EV charging here score 0 since there is no present in the building. So this slide shows the upgrade simulation results from the new wing. 3 improvements again were tested: the motion sensor with the dimming for the lighting, a central digital platform for monitoring and control, and the real-time electricity monitoring as preparation for the PV integration. These upgrades reduce the overall energy by 7%, as we see here, and raise the SRI to 4, while the building remains at the Class E. The improvements highlight the measurable progress in the smart readiness. In this final section, I will bring everything together. I will highlight the strengths of the platform and the key findings from the case studies. I will also discuss the changes that remain, provide an answer to my research questions, and I will outline possible direction for the future development. So the Smart VR platform combines the SRI, the BIM, and the VR into one user-friendly interface. It is fully compliant with the EU methodology, making it accessible even to non-technical users. Instead of using the complex Excel tool, users complete a simple dynamic questionnaire, and the platform automatically generates an SRI certificate. Its accuracy has been validated in real-world case studies. Now, what makes the Smart VR unique is that it goes beyond assessment. With the integrated upgrade advisor, users can simulate potential improvements and see both energy savings and the cost impact. The manuals and the VR features improve the understanding and the user experience, helping drive the digital adoption. And in short, Smart VR is not just a scoring tool. It's a step toward the smarter, more connected, and future-ready buildings. Now, building on the highlights, our findings show that the Smart VR platform consistently delivers accurate and fully EU-compliant SRI results, while remaining simple enough for all types of the users. It enables informed decision-making through its realistic upgrade advisor, and it performs equally well with both highly detailed and more basic BIM models. The results are presented in a clear and engaging way, which makes the process not only reliable, but also practical and scalable. In short, Smart VR demonstrates a real potential to support the wider adoption of the smart building assessment across the EU. Of course, the main challenges I faced in my research were the incomplete BIM data, gaps in the standardization, and the lack of the national accreditation or the training for the SRI. In addition, the upgrade advisory economic assumptions vary by the local content. So these barriers show that broader adoption will require embedded data, stronger regulation, and also digital training. Here I show how my research questions were addressed through the platform. The first question asks how integrating the BIM, VR, and SRI in a unified platform could improve the engagement and enable the immersive real-time assessment. The Smart VR platform achieved this through the immersive navigation, real-time scoring, and interactive metadata supported by the flexible service-oriented architecture. The second question focuses on the simplifying SRI method A. Here, a dynamic multiple choice questionnaire was developed with adapt to a built-in metadata and reduce the complexity while still maintaining a compliance with the EU methodology. Finally, the third question looked at the scalability and the tailor upgrade recommendation. The upgrade advisor addressed this by simulating a control level improvements, computing both energy and financial impacts, and providing target recommendations for retrofits. Together, these outcomes demonstrate how Smart VR responds directly to the identified research gaps. Looking ahead, the Smart VR platform has the potential to go much further. The next steps include integrating method B, which is more questions will be added into the questionnaire. For the BIM data input through an AI in order to reduce the manual work, and involving the upgrade advisor to factor in life cycle costs and the carbon emissions. Just as importantly, collaboration with the public institutes and pilot projects in real buildings will be vital to scale adoption. And my vision is that for the Smart VR to grow into a scalable, future-proof platform. Before concluding, I would like also to acknowledge the Smart PR project for supporting this research. I am also proud to share that the Smart PR received the Best Pitch Award in the Sustain Eurocluster Networking event in Thessaloniki, where it was recognized among 35 projects for its innovation in building intelligence and sustainability. Thank you, and that concludes my PhD thesis preparation. Thank you for attention.
Ευχαριστούμε, Klitou. Thank you very much, Klitou. Very nice work, I have to admit.
Γιώργο μου, να το οργανώσουμε λίγο.
Very, of course, yes.
Leon, thank you very much for your presentation. We now have time for some short questions from our committee members. I would like to start with our colleague Andrea Ferrantelli from Finland. Andrea, would you like to send your questions to Klitos?
Hello, yes, Klitos, really compliments for a nice thesis, nice work, lots of work, complicated and everything. So how much time do we have? Like 10 minutes, I assume, something like that? But it's...
I would say yes, Andrea, so you have your time.
Yeah, but anyway, I have a few generic questions, nothing really too specific. So one thing which is, I also was thinking about it when I'm reviewing your thesis, is how is occupancy scheduling implemented exactly?
So,
Because,
thank you.
Yeah.
Thank you very much for the comments. About the occupancy, I will have to say that about the SRI is not so important. So it's not like the EPC that we care about the occupancy. In the SRI calculation, we don't put anything about the occupancy in the calculation engine. But for future development, if we are going also want to include the EPC inside, we may need to include the occupancy also.
And why do we need to include occupancy? There is a specific connection to occupancy in the output of the engine.
It's not about it's about the comfort of the occupants that it's not how many people are in the buildings, but how the building interact with the users and how comfortable is the environment for them to live inside.
And is there also some other, yes, and is there also some other important impact of occupancy, which is reflected on the building's output, let's say, or?
Yes, but if we are going to go through the official tool of the European Commission, they don't have anywhere to input the data about the occupancy. So they don't include in the calculations the occupancy in the methodology for now.
Yeah, so maybe we can go a bit, yeah, this was just a generic comment, and then we can go a bit further and more into detail. I have a couple of questions about your presentation. So we can keep your presentation as, you know, the blueprint. And there is something, convenience, slide 14. If you could just go to slide 14. There's a parameter, 1.4, yeah, very beginning. Yes, 14, 1.4.
Yeah.
Yes, there. So what about this convenience parameter? Can you explain a bit?
Which one?
Convenience is the one with the coach, or?
Yeah, it's about how convenient it is for the user to be into the building, how easily and how not comfortable, because there is another for the comfortability. Yeah. Is how the user experience in the building.
And
it's the user experience of the house, for example, for the.
Okay. How is that quantified? Just in general, you know, I don't want to know the calculations, but just to have an idea, how do you quantify this convenience parameter?
It's a methodology that the SRI goes through. It's just some parameters that we put inside. And also I have to say that all these they have a weighting factor that for each country that this can change. For now, it's just an overall weight factor, but in general, if we are going to go through the implementation for the SRI into each different EU country, the weighting factors will be changed for each one. That's why we need to select a country in the first parameters that we have of the questionnaire.
All right. Just interesting to check it. And then you have energy flexibility and storage. So how is that parameter implemented? Is it coming right away from the software? Is it coming from, how have you implemented this factor here? Is it connected to the grid or, that's one, energy flexibility storage.
So for example, this one is more related for the energy grid, how well we integrate with the grid, and if we have any storages for each of the domain. So for example, if we have any batteries about the PV systems, if we have anything heat tanks for the heating domains, is how we can save the energy that we have and how we can interconnect with the energy grid. It's something now that we don't have in Cyprus. We cannot interact with the grid at all. That's why the most of the values for the energy is very low.
And why is it 100% heating? I mean, what does it have 100% for heating?
Because we have heat vessels. We store the hot water that we produce through the heat. And this is an example of the certificate of that is given by the EU. In the numbers, I'm not sure if they are correct, but I can tell you that for the heating, it's about the heating storage that we have. As we heat the house, we store the energy, the hot water that we produce. Like, for example, also in domestic hot water.
Yeah, I see 100% as well.
Yeah.
Okay, very good. Okay, then yeah, there is something. Yeah, I just would like to know about slide 37. 37, yes. 37, I mean. But
yeah,
exactly. So can you just explain me quickly just about this control level? I see 1.1. Was it between 0 and 3, you said? Or is it
the control level is coming from the bulk coefficients. So here are the numbers are given from the bulk coefficient, efficiency factor. So the 0, 1, 2, 3 are the functionality levels. So if I want to move from the 0 to the 3, in order to find the coefficient of factors, I need to divide the 0.8 by the 1.1. And then for the energy savings, I just do the energy in kilowatts per meter square minus the energy used times the coefficients of the savings.
Okay. Yes, this comes from the European Union standards, I think. Okay. Yeah, all right. And yeah, and then there is something which is interesting, I think. Slide 51 maybe.
51?
Yeah, it's about the comparison between the user and the SRI officer results. Yeah, so what is interesting is that the user got, in the specific case, G class for the SRI. I mean, for SRI, they got G, while the officer got F. So now, this I think is the outcome from this is the outcome from the advisor. So why should we take both user and advisors SRIs if at the end we have the advisor SRI?
No. Here is not the advisor's SRI. After I have complete the upgrade advisor total cumulative about the energy savings, I went back to my SRI tool and I have done again the SRI with the upgrades in order to see the new class. That's why I compare the G with the F, because I have done the changes into the tool, the SRI tool, not the upgrade advisor. The upgrade advisor just give us the energy savings.
Okay, no. Okay, now I got it. I just thought there was like a user-based and because I kind of remember from the thesis that there is a user-based and there is assessors-based type of smart bear interface. Was it so?
For now, there is not, but maybe in the future we will provide that.
Now it's only user.
Yeah.
Okay, now only user. Okay, I just got a bit confused in that sense. Okay, so and yeah, 55. Let's go to 55. I'm quite done. Just 2 more questions. Yeah, be here. There was occupancy. Was it this one? There's an occupancy as a parameter somewhere. But anyway, yes, my question is
about the information to the occupants, the last impact score, but it's not about the occupancy, it's about the information to the occupants.
Yeah, so again, my question is, when I'm just a bit bothered about this occupancy, taking into account the occupancy, how is the different type of building, because occupancy is important about the different typology of building. For instance, the occupancy schedules change, they have an impact of something, right, which is changing in the building, the occupancy, the occupant activities.
So sorry to interrupt. About the occupancy, we have in the beginning of the SRI, when we can select the type also of the building, either residential or non-residential. And this is again change the weighting factors of all the impact scores. But we don't have anything to change about the schedules or the impact, the occupancy. And this is how the SRI calculations come from the standards. We didn't change anything about the calculation methodology. We just make it more user-friendly with simpler questionnaire and a better visualization.
Yeah, I was just trying to understand because I also read the thesis and there was something, I understood that all the physical simulations, or let's say not simulations, but the physical calculations, and also this kind of more statistical oriented studies about, for example, occupancy, again, they are embedded into these factors, right, into these coefficients. So by selecting the different type of building, you take into account occupancy on an implicit level, let's say so.
It is taken at the backbone of the SRI as you change for the residential and non-residential.
Yes, exactly. That's where it goes. So now it's clear. Okay, very good. So last couple of questions. So these are more generic. What was the most difficult task for you in this work?
The most difficult part is that we are like a lot about the BIM models. We are far behind what we want. And that's one of the problems that I may face with my tool, that we don't have a lot of information. We don't have a lot of buildings that they have the BIM models. And now also with the building logbooks that are going to be implemented into the EU, they will be mandatory for all the buildings to have the BIM models. So for me, it will be easier to take the models from there and put them in my platform. And also the way that we build, as I said before, we don't need to have a detailed BIM structure. We just want the map systems and only the geometry that the user can go through and see what systems are included, how they work, and they can do the SRI calculation.
Okay, yes. It's understandable. It's understandable, absolutely. So very last question, what are your future plans?
Okay, my future plans. First of all, I want to go to both directions, academic and in the market. About the academic, we can use this platform in order to train the assessors, the SRI assessors, with different scenarios of beams that they will be different scenarios of the buildings. They can train in order to complete the SRIs, and after making this assessment, they can be certified as SRI assessors or something like that. And about the market, as I said before, this project was under the UFIA Tech, and in the future plans, we have to open to the market the platform, and we will sell license to the users in order to use our platform. But we have to make some changes about the national regulatory systems that we have to change some of the weighting factors, all this, but is in the future plans that we have.
Okay, very good. Okay, thank you very much. So I'll give round to my colleagues. Thanks a lot.
Thank you, Andrea. We move now closer from Aalto University to Northern Greece, Western Macedonia, George Vanaras.
Okay, Paris, no, Aristotle, not Western Macedonia.
Sorry. Okay,
Okay.
Congratulations. It's
Thank you.
official. So
Thank you. Yes, it's official. Yes, thank you.
Okay.
So, yes, Theoklitos, congratulations for your work. It's very interesting. Yes, and okay, I don't know, this combination of these three, let's say, not tools, perhaps concepts, you demonstrated that it can produce some very interesting results and, of course, facilitate and enhance the relevant procedure. What I wanted to ask you, I want to go more on some things about how we identify or how we understand the results and the energy performance of buildings mainly, and not that much on the, let's say, on the technical VM or the programming approach itself. So one question I have, it was also indicated by Professor Ferrantelli, also by Andrea, and I would like to ask you about, okay, we talked about the occupancy. You said that it has some parameters for not for the occupancy, but for the satisfaction. Can you please be more specific on this? Which are the parameters? Which are the parameters that we need in order to quantify the satisfaction of the users according to the SRI? And I am asking you because I want to make a second question that I want to ask you in some other also, let's say, categories, if you think that they are adequate, these parameters, for example, and to have some discussion on this. But let's stay, for example, for the indoor environment, I don't know, comfort, satisfaction.
Yeah. So about the indoor conditions, about the human comfort, we can see either from the heating or cooling or the lighting, or again from the ventilation or the dynamic envelope. If we have some automations inside, for example, some blinds that they can close in order for the glaze of the UV that they can block, either for the heating, in order to have a standard temperature that it needs to be inside each different room and not the whole building. For the lighting, if it's possible to be in dimming with the outside conditions, and also with some sensors, when the person is coming to the room, the lights will become on. So these are the types of information that we collect for the SRI, and how we see with the human comfort of the building.
Okay, for example, for thermal comfort, is there a model that quantifies the thermal comfort level?
No, for what the calculation is if there is presence or not, how it works, if it's automated or not. It's just 4 questions that you need to answer. You don't have a standard to say that it needs to be at the 22 degrees, for example. It's just if it's presence or not, how it works, if it's automated or not, and if it's great or not.
Okay, and what about presence? Now you said if it's there is presence or not. How do you, it was discussed earlier, but I didn't understand. How do you identify presence with
The
your
presence
tool, perhaps?
is for the lighting mostly,
Okay.
and you can control that with the sensors, either infrared or occupancy sensors. That is just, again, in the questionnaire, is just if there is presence or not, if there is also a manual option to close the lights or turn them on. It's just simple question. You don't go to details on the SRI questionnaire.
Okay. Okay.
The method C has a different approach where you put all the data coming from the building, the real-time data, and then you have some indicators that you need to set as a baseline in order to have the SRI calculation.
Okay,
But this is a different
yes.
approach. We talk now about the method A and method B. That is about the functionality level. Select which functionality level it is, and that's it. You don't go through more details on that.
Okay, but concerning that was another question I had concerning methods A, B, and C. You work with method A only.
Yes, only,
Okay.
but in the future, in order to go to the method B, it's just another 20-25 questions that we need to include in our questionnaire. It's not something that is known. It's in our next moves in order to include that one also.
Yes. Yes, but that means that if you go with method B or method C, the evaluation would be more complete, or the results would better correlate with the indoor environmental quality and the energy performance of the building? I mean,
for method C, definitely. For method B, it's not so much difference from method A. It's just some fewer, method A has fewer questions. It doesn't, again, you don't put any real-time values inside. Only method C.
okay, but what's the practice? What do we need? I mean, I have to have SRI for my building. What are the requirements from the legislation?
For
Which
now,
method can I? Yes.
For now, it's nothing, but from 2027, is mandatory for all non-resident, big non-residential buildings for more of 290 kilowatts to have an SRI certificate.
Okay, and which method should we implement, or we would be free to
That will
select?
be method B. That will be method B for now, because it's for non-residential and more complicated buildings.
Okay, method B. Okay, so yes, with your experience now, because I'm very interested on the performance of buildings and the relation of SRI mainly, that's a more specific question. With your experience, the SRI, what is its actual contribution to our, I mean, for example, we have energy certificates that give us something very specific. The energy certificates provide us specific knowledge about the quality, let's say, of the construction and the energy efficiency of the systems. What about the SRI? You had perhaps another, but the SRI, what does it actually, I understand the parameters, but actually, if we have a high level, what does it mean at the end?
So yeah, thank you for the question. So we have, as a certificates, we have three different things. We have the SRI, we have the APC, and we have also the energy audit. These are very different scenarios. For example, the APCs, we care about the U values, the occupancy of the house, the patterns and everything, about the, for example, the class of the heating and for the HVAC, what are the classes and what are the efficiencies of each one. For the SRI, we don't care about the exact numbers. We care if there is a present, it's about the automation and how it interact with the grid and optimize the energy. So it's the three pillars I have here. It's about the optimization of the energy, the occupant needs, and about the responses to the grid storage. It's only about the three pillars. We don't care about the building envelope so much. And that's the difference. And also now, because I was also working on the exercise, how to integrate in a certificate the two assessments, the EPC and the SRI. For example, we don't have anything about the automation and how it interact with the human needs. What are, if there are any, sorry, how is optimized that communication between the occupant and the building. And this is something that we don't have in the EPC. That's the main difference is about the automations, is how smart the building it is. We don't care about, maybe you can have an EPC of a class near zero, and the SRI must be maybe is 5%. Or maybe you can have a very smart building with an EPC of C or D. Yes, they don't go together.
Okay. Do you think this is a limitation of the SRI, or what could be a solution for this? Because I would say, as a mechanical engineer, why should we care that much for the automation, given that we have a good energy certificate? I mean, what's the after all, through this discussion, the importance of SRI?
Yeah.
Or how could it be improved? I'm talking with your experience.
Yeah.
Yes.
So one of the challenges that we face now is how we can integrate the two assessments together in order to have a unified assessment. In order to have one certificate that we have both of them inside. And that's there we can also see the performance of the building and how its automations work. But okay, if we just see the two different things separately, if we have a near zero building with no automation inside, the human comfort inside may be very low, because we don't care in the EPC about the human comfort, we care about the performance of the building. And in the SRI now, we care a lot about the human comfort, and it's one of the main pillars, so that's why. So it's from how you want to see the things. For me, it's more important the human rather than the building. But in order to have both of them together, you need a centralized solution.
Okay, and I have some questions, one or two questions about the advisor, because that's very interesting, a very interesting aspect of your work, that we can have an advisor. And I want a little bit that to explain me how, what's the background of the advisor, what's the main scope, and how it works.
So about the advisor, it was an exercise that we have done before about the impact efficiency factors. And from there, we have done also the Excel sheets about the different smart services with the functionality levels, and we tried different scenarios about IRR, cost of energy, and also the different, how we call it, spaces, the heating spaces, for example. And we end up with a lot of Excel sheets that have different values inside, and we want to make them all together in order to see how, by changing the functionality level that we want from the existing functionality level that we have to an upgrade scenario, what will be the value. And also we wanted to see if we have done 3 or 4 changes on the systems, what will be the cumulative of that. And that's how we end up with the advisor, and that's why we have the Excel sheets now and not the Python code behind, because we have done all the work in the Excel.
Okay, but I'm a user. I use your tool. I have your tool, and I have a result for my current SRI level. And then I want to implement the advisor in order to improve. What's the actual output of the advisor?
The actual value is the percentage of the energy the efficiency that you will have.
Okay, how do you calculate, for example, this efficiency? Can you tell me a specific example of what the advisor does?
For example, for one of the case studies that we have done, So in the beginning, you put the cost of the energy, the IRR, and the functionality level that we want to go from to the upgrade one. This one have behind an Excel sheet that says for this IRR and this cost of energy, for these square meters of the building, you have that value of that cost of energy per square meter. And in order to move from that bug efficiency to the next bug efficiency with, for example, 0.9, what will be the efficiency, the total efficiency in the value? And this gives us, and this compares the previous with the one you have, and it gives you the value.
The payback period, you mean?
What?
The payback
No,
period?
no, it doesn't give you a payback period, just the energy efficiency percentage for the cumulative.
You showed, I think, an example there, but it's okay. Yes, you showed an example about the advisor with some measures.
This
Okay.
one?
Yeah, so if it means that if I put motion sensors with dimming, for example,
The lighting control, you have an energy saving of 8% with allowed investment of 10.37 euros per square meter.
yes, Theoklitos, that's my question. This energy percentage of 8%, this is calculated through the SRI, or you have a different model?
No, it's a different model. It's the Excel sheet that we have done with the different cost of energies and different IRRs for each factor.
Yes, but it's not only the cost of energy, it's also the energy saving itself. I mean, if I have a better light, how can you calculate the output on energy level?
These are some assumptions that we have done in our tool. Because I have explained that before. Here. So here we have the control levels is the bulk efficiency factors. Okay, from the ISO, we took them to the coefficient of savings. What we have done is that in order to go from functionality level 0 to functionality level 3, we have divided the 0.8 over the 1.1 in order to find the 0.74. Then, in order to move to the energy savings, we have done the energy use of the kilowatt hours per meter square minus the energy use again over the times the coefficient of savings in order to find the difference that we are saving. And then if we wanted to do the percentage, we just have done the energy savings of the kilowatt hour meter square over the energy use, which the energy use we defined it in the beginning. I don't have it here as an assumption that is 150 kilowatt hours per meter square. This is an assumption that we have done in order to proceed with our calculations. This can change if we are proceed to the Python in order to be also human interactive.
Okay, Theoklitos, thank you. And one last question about the two case studies that you showed us. My question is that, okay, we have two case studies. Why are your tool has demonstrated very good validation, but I want to ask you, why are these two case studies are considered sufficient for because I'm a user, I would use your tool in another climate, in another, I don't know, building use, in other conditions. Why these two case studies are considered sufficient? Are there some critical parameters that you identified that these case studies cover? I mean, how can we generalize what you showed us for two buildings for, I suppose, all the buildings of the tertiary sector, I think, or something like that, non-residential?
Yeah, thank you for the question. As I said in my feature work, is to done some more pilot testing. For example, these two, I select them now in order to present it to you because they have a different usage and also a different beam detail. And I just wanted to show that also a more detailed BIM file can be also. Sorry.
Έχετε το μικρόφωνο σας ανοιχτό, ίσως.
So
Yes.
yes, that's why we just show these two pilots now, due to the BIM difference of the details, and also about the usage, and also that one is more complex than the other. Then
Yes.
as I said in my next steps, we need to do also some pilots for more residential buildings, some more complicated non-residential, in order also if we are going to implement the method B, to test also the method B, and if we want to move to the market.
Okay, but according to your experience, with the demonstration you did, with the validation you did, do you think, or which parameters do you think you didn't consider, or you would like to consider in a further validation? Which are the parameters? The use of the building? I don't know. The climate?
It's also,
which are if you had to select, I mean, you have some limited time or some limited sources, and you want to generalize, which are the critical parameters that affect such a validation for your tool?
For my
With your
opinion,
experience.
is the user engagement. The whole point of my platform is to be accessible to all the users, because I know that the SRI, the tool is tested through many more case studies, and it's correct and it's validated with the EU tool. However, the VR and the BIM is a new experience that we put into the user, and that's the most critical one. And that's why I want to use these two case studies in order to show the different approach of the user, that they can see also just 3 small offices with a full detailed BIM, and also they can have a huge building with different uses. For example, canteen, lecture rooms, and offices, and with nothing inside, nothing detailed, just the map systems, that they can also proceed with the SRI calculation.
Okay, thank you, Theoklitos. I think I took too much time. Thank you very much. Congrats for your work. I wish you the best, and okay, thank you.
Thank you very much. Thank you.
Now, okay, we move southward to the beautiful village of Fokaides and to our colleague, Professor Karagiorgis. George, can you hear us?
Hey there. Klitou, you have done good work, I have to admit, I have to say this. I like all this idea and the way you have analyzed your results, your SRI analysis, this tool. You know, I would like to make a more generic question. If I could ask you, from all this work that you have done, what is the single most important contribution towards a PhD? What would be your answer?
So I will have to say that I have developed a unified digital platform that integrates BIM, VR, and SRI. And also in this platform, I also integrate the advisor. That is something new. No one has done it before. They didn't include the advisor into the SRI calculations. And that also can be used for experts and not experts in all the fields. That's the most important thing that I think my contribution as a PhD has.
So that's a contribution to knowledge. And you consider this tool to be easily handled by somebody, someone who use it? Is it user-friendly, you think?
As I said before, that what are my future things that I said about the academic and the market? I want this tool to be used also by academians in order to train the advisors. So we have also the use of the platform as a training, and also as an assessor. I can use it for some buildings that they are not built yet, in order to get into the building through the VR and do the assessment. And also about the retrofitting, if I want to make a change due to the retrofitting of a building, to be easier to understand the scenarios that I'm going to do. So it's about it's for all users, as an assessor, as an architect, as just a user, an occupant of the building. I think it can be used for everyone.
All right. But as our colleague, Mr. Panaras, asked you, the validation, you have tried with a limited amount of buildings. You have any plans to apply it to more buildings so you validate your results?
Yeah, in the next steps that we have is to test more pilots. So for now, we have only used for non-residential that we know are more complex and difficult to be assessed. And the next steps is to have at least 2 or 3 pilots for each case. For example, for a small residential, a big residential, a small non-residential, a multi-use non-residential, in order to have the scenarios for every case and see our validation. But as I said, the SRI as the tool of the quick SRI that we have done is validates. But the platform, the whole platform with the VR and the BIM is not yet full. We have 4 buildings, but again, I think it's better. No, I think it's sure we need to make more pilot testing for that.
Okay, basically you have asked a big part of my next question. I was going to ask you how you see your work evolving in the next couple of years, but you have already told us that you are interested to be both in academia and in actual business promoting this tool. You told us about your plans. However, give me a complete answer on how do you see this work, even though you said you're going to do some more validation, all these things, but how do you see this thing finding its way towards its commercial application in the next 5 or 10 years?
So I think Dr. Andres asked me before if we have different users logins in our platform. So one of the things that I want to do with the platform is to have different login scenarios in the platform. For example, about the academician, I will have a teacher or an assessor that wants to be certified to go through my platform, do some trials, do a testing about the SRI for a case of a building, and then get a certification that, yes, you know how to complete the SRI and you know how to understand the scenarios of the SRI. Also, I want about the assessors, the certified assessors, to have access to the platform, to produce some certificates about the different scenarios for different buildings, and this will be directly linked into the digital building logbook of each EU member state that we are interconnected in order to have centralized information about the information.
Okay. Okay, I don't have any more questions, but thank you very much.
Thank you very much.
Thank you, Giorgos. And we are reaching now the last member of the committee, our very good colleague, Professor Loukas Papadakis, who is in the room with us. Loukas,
first of all, I would like also to congratulate you on your work in overall and for today's great presentation.
Thank you very much.
To the spot, because we have discussed also offline in the background about the different technical stuff that I was not quite convinced of, and you have implemented them all in detail in your work. Thank you for that.
Thank you.
The last question, I think it was not answered. I understood that you have created a kind of spin-off based on that, or at least companies.
The spin-off was established before, but
it doesn't matter. What are your intentions in really concretely commercialize this software? Are you going to try some ways in a lower SME level as a software developer, or are you thinking also to addressing some big players and going a little bit further on that? You don't have to reveal that.
Yeah.
But
I think
it's my last and only question.
That's why I told before that I want also to be in the academia and also in the market, because through the academia, about training of the assessors and everything, if the trainings get to know the platform through the training, then they will be easily used in the field, and they will need to pay us a license in order to get a certificate.
And my question was really practical about commercialization of that. You have a very good tool now, and you have a lot of elements which can really go to detail and be extended. And you can, I'm just making a joke now, perhaps it's not a real joke, perhaps you have this intention, you can perhaps create a Google app that you click there instead of, apps and photos, and say a building evaluation, and you can really extend all these features that you have in a good manner in an overall software that can be used by, as you said, everybody or scholars or whatever. Because it's a very good idea. You can think about that in your team. Congrats again.
Thank you very much.
I would like to thank everyone for attending this exam. To the members of the committee, you will be sent the sort of minutes of this exam, and you will be requested to give your comments, either to approve or to give any comments that you may have. Andrea, Giorgo, thank you very much, and Radula, of course, thank you very much for your remote presence. And you will be kept posted in the next steps for the next steps of the procedure. Thank you very much.
Bye.
Thank you, everybody.
Thank you very much.
Bye.
Bye.
Theoklitos. Bye. Thank you. Bye.
Moment, dat